Hello, ladies and gentlemen. All right, so the vertex form of a quadratic expression is what we started talking about today. And this sheet, page 79 in your workbook, and we're going to go up to page 81. So we started talking about the vertex form, which is right here. It's the vertex form of a quadratic, and notice the formula is ax minus h squared plus k. The minus is important. We're going to come back to that. This is your factored form, which is a bracket x minus s, x minus t. Now remember, s and t are going to be numbers, right? So an example of this might be 3x minus 2x. Now if t was in fact a negative 1, it would be negative and negative, so maybe it's plus 1. So that would be in factored form, so your intercepts would be x equals 2 and x equals negative 1. This is vertex form. Maybe it would look like this. X minus 2 squared plus 5. Okay, just made up those numbers. And this maybe is 3x squared plus 2x plus 5. And that would be in standard form. And they all do something different. Standard form is really great for being able to use the quadratic formula. Factored form is really great for being able to set it equal to 0 and solve quickly. And vertex form is really great for being able to determine a vertex. Now the vertex here is going to be at vertex is going to be h comma k. Now notice in the formula it's negative. And here we use whatever the value of h is. So if I had this, y equals 3x minus 2 squared plus 5, then my vertex would actually be 2 comma 5, because see, there's the negative, and that means that my h value was in fact positive 2 with my negative. Okay, now if I had something that looks like this, x plus 2 squared plus 5, now that's a little bit different. This is supposed to be a negative, and it's showing up as a positive, which means that that h value must have been negative. What that would look like is 3x minus negative 2. So now you can see the negative that's supposed to be in the formula. Your h is negative, and you can tell that they go together to give you that positive. So this vertex would actually be negative 2 comma 5. And that's why that works. The a value is going to tell us a little bit about the direction of opening, whether it opens up or down, which is going to tell you whether you have a maximum or a minimum value, and it'll also give you the shape of the curve. So in class we went over this, and we talked a little bit about it. So this is in vertex form, which means that the vertex is 2 comma 1, which means you go over to 2, up to 1, and that's its vertex. The a value is 3, so it's greater than 0, so it opens up, which gives you a minimum point on the curve with a minimum value of 1. So the function is y, the minimum value is 1, and it occurs when x equals 2. This one over here, you're going to have a vertex of negative 3 minus 4, so it's there. You notice that the a value is negative, so it's less than 0, so it opens down, so that's a maximum. The maximum value is negative 4, and it occurs when x equals negative 3. So there's a lot of information that can come out of the vertex form. So what we need now is a method for converting quadratics in standard form to vertex form. And that's what we're doing. We're going to go from standard form to vertex form. And I'm going to teach you a method of doing that. It's actually one that you know already. It's actually called completing the square. And it's called completing the square because you're taking this and we're going to create this perfect square binomial here. Okay, so we're going to take this and we're going to be able to create that from this. And I'll show you a way to do that. So we're going to flip over, and it's going to be our first example. Now I did it in class, but I'll do it again with you, and I'll be right back to do that.